Alright, in 10.1, we want to review some topics that we covered last semester that you're going to really need as we move into this new semester. So all of these things you should have seen before. I'm just kind of jogging your memory on them. So let's look first at systems of equations. The first thing we could do is solve these systems by graphing. Now, if you notice, these are not in y equals form. So the first thing I have to do is move them into y equals form so that I can put them in my calculator. So if I do that, I'm going to keep the negative 4y on the left, and I'm going to move that 3x over here. So it's going to be negative 3x plus 2. Then I need to divide through by negative 4. And that will give me y equals 3/4 x minus 1/2 because I'm dividing by a negative. So there's one equation I'm going to put in. Now if I take this one and I'm rearranging it, I'm going to move that x over. So 3y equals, it will now be positive x plus 1, divide by 3. So y equals 1/3 x plus 1/3. Now, I want to put these in my y equals, so let me show you how to do this with fractions. You got to make sure you're comfortable doing this with fractions. So, alright, so when you put this in your y equals, to make a fraction, you're going to hit alpha y equals, and it's going to give you this fraction setup. That's the best way to do it. When I put that first equation in, I'm going to put 3 over 4 x minus alpha y equals 1 over 2. Second equation, here we go again. Alpha y equals 1/3 x plus alpha y equals again 1 over 3. Alright, now they're in there correctly, and I can look at my graph. Now, if your graph is weird, it doesn't look exactly right, let me remind you, you can always hit zoom 6, and that will reset it back to the standard 10 by 10 square. But what I'm interested is, remember, the intersection is the solution to this system of equations. So to get the intersection, let me remind you of the keystrokes while we're waiting on this to go. You're going to hit second, then you're going to hit calc, and you're going to hit number 5, and then you're going to hit enter, enter, enter 3 times, and then it will generate your answer for you. Okay, so we're looking for this point right here. Okay, so if I hit second and calc, it's right there above trace. I want number 5, the intersect, and I'm going to hit enter 3 times. 1, 2, 3. And there's my answer, 2, 1. I don't know if you can see that, but it's 2, 1. So my answer is 2, 1. And my graph is the one that gave it to me. Now that's solving by graphing. Fine and good. Now remember, we also solved by substitution. So let me remind you what we did. We took one equation and we solved it for a variable. I'm going to take the second equation and solve it for y. So it's going to be y equals, I'm going to move that 2x plus 9. Now I'm going to substitute that into the other equations. It's going to be x plus 2 times whatever I just found for y, 2x plus 9 equals 13. So now we've got it down to just one variable, x's. So I can clean this up, distribute that 2. So 5x, I'm going to move that over here, becomes negative 5. So x will be negative 1. Okay, so there's my x coordinate. Now to find my y coordinate, I'm going to take this equation that I had right here. Y equals 2 times negative 1 plus 9. Negative 2 plus 9. So y is 7. So my solution is negative 1, 7. All right, that's systems of equations. Now, let's talk about quadratics. Write the equation in vertex form given the vertex and the point on the graph. So when you're doing this, maybe you need to remember the generic formula for the quadratic was y equals a times x minus h squared plus k. Remember the vertex was hk. So when you look at what they give you, they are giving you the vertex, there's h, there's k, and they're giving you the points part of this equation. They're giving you the x and the y, and we're going to solve for a. This is vertex form. This is what our answer needs to look like. So let's try this out. So y is -2 equals, we're going to leave a alone. X is 1 minus h, so it'll be plus 3, don't forget the squared, plus k. So 1 plus 3 is 4. 4 squared is 16, so I'm going to write this as 16a plus 6. I'm going to move that 6 over here. It's going to be minus 6, so I'm going to -8 equals 16a. Solving for a, so I'm going to divide by 16. And we're going to find that a is equal to -1/2. All right, so I need to write it in this form. So I'm going to say y equals, I'm going to replace a with -1/2, x minus h, so it'll be plus 3, squared, plus 6. There's my answer in vertex form. All right, let's try another one. My vertex, here's h, here's k, here's x, here's y. So y1 equals a times x is 0, minus h be plus 2, I square it, plus k. Let's solve this out. So 1 equals 2 plus 0 is 2, square it is 4, so 4a plus 6. I move that 6 over, I'm going to have -5 equals 4a. So a is going to be -5/4. So I'm going to write it in vertex form, my answer. So -5/4 times x minus h, so it's going to be plus 2, don't forget the squared, plus 6. There's my answer. All right, that was vertex forms of quadratics. Let's look at finding zeros using our calculator. So really, there's not much room here because there's not much work to show. You're going to put all of this into your y equals. All right, and I'm going to walk you through it and we'll write down our solutions. But put it in your y equals, and then you're going to hit second, calc, and number 2 says 0. So let me show you what that's going to look like. Okay, I'm going to go to my y equals. I'm going to clear everything out, and I'm going to put in this equation. 3x squared minus 5x minus 4. All right, if I graph it, let it graph, I can see it's crossing the x-axis right here and right here. Remember, that's what zeros are, x-intercepts. But I can't exactly tell what these points are. So I'm going to do second, calc, which is right above trace, and I'm going to choose number 2 for 0. Now, remember, if I see the blinker on there, if I take it it says left bound, so I'm going to go just to the left of where it's crossing this x-axis. And it's going to make a little triangle. And then I scroll to the right of it just a little bit, hit enter again, and it's going to make another triangle. So it's saying I believe that that intersection is right between those two triangles, so hit enter one more time, and there is one of my zeros. So I'm going to write this as -0.59. And 0. And then I know it's crossing over here as well, so I'm going to scroll. I'm going to do this again. I'm going to do second, calc, 2. This time I'm going to scroll this way. I'm going just to the left of this one. It feels weird because it's below it, but it's left of it. And then I scooch a little bit more, and now I'm to the right of it. Hit enter again, and there it is. Now, this, I don't know if you can read it. It says 1e to the -12. That's like 11 zeros and a 1, 0.0001. So what's happening, your calculator, it's trying to make it 0, but it's not exactly 0. So that's good enough for you to know that this is the 0. So my x value is 2.26, and the y value is 0. Although it doesn't say exactly 0, it's just getting stuck on a pixel on your calculator. That's all it is. And you know that because it's such a tiny little number. All right, let's try the next one. Solve each quadratic by factoring. So this is just factoring stuff. So if you remember, we want to start this by set the quadratic equal to 0 first. Okay? That's the first thing you want to do on these, because we're going to be factoring. So notice, I need to move some things over for this to be equal to 0. So I'm going to move this over here. So I'm going to 2x squared minus 8x equal to 0. Now, if you remember, when we factor, we always look for a GCF first, right? Yes, there's a GCF in this one. I can factor out a 2 and an x out of both terms. That leaves me with x here and a 4 there. Now I can set each factor equal to 0. So x will equal to 0 here. Set this one equal to 0. X equals 4. So there's my solutions. X equals 4. X equals 0. Let's look at number 7. All right, it's all set to equal to 0, but I always want to look for a GCF first. I know I can take a 3 out of each one of these, so I'm going to do that. If I factor out a 3, I'll have x squared minus 10x plus 25 equals 0. Now I need to continue factoring, so I would do a multiplication chart. So I need to multiply 1 times 25 to 25, and I need to add to a negative 10. So think about factors that can get me to 25 but add 10. Well, 5 and 5 for sure, but I needed to add to negative 10. So if I make them both negative, when I multiply it becomes positive, but when I add them it will be negative 10. So I know it works. So now I can go x minus 5, x minus 5, and I just bring that 3 straight down. Now, why did I go straight from my table here? Remember, if that coefficient right here is a 1, you can go straight from the table to your factors. So, that 3, when I go to find my solutions, there's no solution here. Because you can't set 3 equal to 0, so there's no solution with this 3. You can ignore that. Now I take this one, x minus 5 equals 0, gives me an x of 5. And since I have it twice, I would just say it's a double. Okay? It's a double root. Let's look at number 8. 2x squared plus 9x equals negative 4. Well, I need to set this equal to 0, so I'm going to move that constant over. And then I'm going to try factoring. Well, I don't see a GCF I can take out. This should be a plus 4. I don't see a GCF I can take out, so I'm going to have to do my factoring. So multiply and add. I need to multiply 2. 2 times 4 gives me 8, but I need to add to 9. So hopefully you catch that 1 and 8 work. So I'm going to split up that 9x. I'm going to say 2x squared plus 8x plus 1x plus 4 equals 0. So then we will do a GCF here. We have 2x. That'll leave me with x plus 4. And here, bring that plus sign straight down. I don't have anything I can take out of these besides a 1, so it's just x plus 4. Now I'm going to notice these are the same, so I'm going to bring that x plus 4 straight down, and I'm going to put these together. So 2x plus 1 times x plus 4 equals 0. Set each factor equal to 0. So x will be negative 1/2. X plus 4 equals 0. That means x is negative 4. So here are my zeros in this case. All right. Hopefully this gives you a good review of all the stuff we did before the break, and will be sufficient to jog your memory. Good luck. We'll see you in class.